Welcome back to Geometry, Chapter 11, Section 2 in this book. We're going to be talking about areas of regular polygons. What are regular polygons? Poly is many, gon is side-ish kind of thing. And regular means all the sides and all the angles are equal all the way around. So it's like a stop sign would be a regular hexagon because all the sides are the same and all the angles, interior angles there are the same and exterior. All right, so first we're going to talk about triangles. That for any triangle, whether it's regular or not, the area of a triangle equals 1/2 base times height. You learned that probably in elementary school. So here's a right angle and its base is how far across that is. Its height is its tallest part there, okay? If it's a regular triangle, see how I've got 3 little red lines drawn there to show the 3 sides are the same, then it has a special formula. 1/4 times the square root of 3 times sides squared. So for example, if the sides are 8, the length is 8, it'd be 1/4 times the square root of 3 times 8 squared, which is 16 times the square root of 3, which is, on your calculator, it would come out being about 27.7. Now, I am not going to remember that formula. Let's just be honest. There's certain formulas I like. That one, I would second guess myself. I'd be taking the SAT and go, oh, there's a special formula if it's regular. It's got some sort of square root in it. Nope, don't know it. So this one just, I've seen it since I was in high school. You didn't commit it to memory, probably wouldn't use it. Would only use it if I was doing this chapter of this book and could flip back and see it and write it down and then do it a few times. So what I would end up doing I'd end up doing it the regular way. And if I didn't have what I needed for the regular way, I would use trig. Some old horse called another horse taking oats away. Got the button on my calculator, I'm using trig. Because I can remember the horses, drama, I can remember 1/2 base times height. Known it since elementary school. So I probably wouldn't do it that way. And I'm going to show you throughout this chapter that you can do things with special formulas or you can MacGyver it with trig and what you already know. Alright, so here's another one. This one is 8 on each side, so we know that the angles are 60 on each side. So, okay, so this is the way using the special formula. This is my way. This is the way I would really do it. So I would know that each side is 8, and I would know that each angle is 60 because regular, they add up to 180. I have memorized that. I would also know that if I drew my height, that it would bisect my base, and this would be 4, and that I would have just a beautiful little right angle triangle right there where I could figure out the height, and I'm going to use trig. So my theta is 60, and I'm going to write my theta right there, and so I need the opposite. I have the hypotenuse is 8, and I have the adjacent is 4, I need the opposite, which is the height. So I can do some old horse, so it's the sine of 60, that's my angle, equals the opposite is what I'm looking for, x, over the hypotenuse, which is 8. Because I'm not looking at the whole triangle, I'm just looking at half of the triangle. Let me draw that for you so you understand it. So, because the height is the same for this half a triangle as the whole triangle, and right now the only way you know trig rules is if it's a right triangle, and that's a right triangle. Okay, everybody understand that? Alright, so now I'm going to multiply both sides by 8, so x is alone, and it's 8 sine 60, and that's about 6.928. So now I can do my regular formula. I can do 1/2 base times height. Or if I wanted to make sure I didn't lose anything in rounding, instead of putting 0.6928 for the height, I could just put the whole little thing in my calculator, because that's height. That is the height right there, that's the opposite. So I could do 1/2 times 8 then do times 8 sine 60, and I get 27.7. Da-da! I would do this one, not that one. Now, if you just love little formulas and can memorize them and remember them on the SAT, go for it. I can't. I have to just keep it simple and use the certain ones I know really good over and over again. And I know my trick. All right, so here's another one. Some more background knowledge, just like that was. Okay, so here I have any kind of regular n-gon. So it could be a regular polygon, it could be like a hexagon, it could be a pentagon, anything that's regular. You can pretend that you put it in a circle. And if you drew a line from the center of the circle to one of the vertex, that vertex would be touching the circle and it would be a radius of the circle. Can you imagine that? But then you have these flat places that don't touch the circle, and if you draw a line from the center to one of those, it would be shorter. Can you see that? Well, it has a special name. Instead of calling it a line from the center to the flat place, which would help us remember what it is, it has a fancy name called the apothem. That's fun to say, apothem. But it's just fancy math talk for a line from the center to the flat part, where it's perpendicular. And then, of course, the other thing we have in this is the length of the sides. Okay, so the area of any regular polygon, a certain number of sides, is equal to 1/2 times the apothem times the perimeter, or 1/2 times the apothem times the number of sides times the side length, because the perimeter equals the number of sides times the side length. Okay, so that's one way to do it. And if you remember that formula, woohoo! Nothing but biscuits and gravy. You're ready to go. But what if you're me and you forget the formula of the test and it's the SAT and you need the Zell Miller Scholarship? What are you going to do? You can also think of this thing as a bunch of triangles put together. There's a triangle, there's a triangle, there's one, there's one, there's one. Do you see how this is actually 6 triangles put together? And if you can get the area of one of those triangles and multiply by 6, you're biscuits and gravy then too, because you got it. You just multiply it by that. So you can also think of area of one triangle times the number of triangles. And sometimes you might, to make it a right triangle, you would need to divide this into 12 triangles. If you can imagine that. I think they are. Okay? So you might have to divide it into 12 triangles. But if you could divide it into a triangle, get the area of that one triangle using 1/2 base times height, multiply it by how many triangles you have, you've got it. All right, so here's an example. It's a regular pentagon, 5 sides. I drew the circle around it in blue. I drew the radius, and we are told the radius is 1, and that's all we got. That's all they gave us in this problem. Now, so we can think of it as 5 triangles that are 1 on each side, and half of this, we don't know what the bottom is, but we know the radius is 1. It's not that each triangle is equilateral, it's that each triangle is the same, is what's making it regular. And each angle is the same. Okay, so if you're right here and you went around in a circle, don't you agree that's 360 degrees? So this is made out of 5 triangles. You see that? 1, 2, 3, 4, 5. And so I can take my 360 degrees and divide it by 5, and I would get what this angle is right here, that whole little angle on each of the 5 triangles, and it's 72. 360 divided by 5 is 72. But I only know trig with right triangles, so I only want half of this, because I need it to be this right triangle right here. So I'm going to divide 72 in half and get 36. Now I can use my trig rules and I have the hypotenuse and I have theta, so I can get opposite and I can get adjacent. I can get opposite using some old horse, and I can use adjacent doing caught another horse. So sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse. So sine of 36, because that's my angle, equals, so that make sure you understand that's your theta, equals opposite, and I don't know what this is yet, over hypotenuse 1. So I multiply both sides by 1 to get rid of that 1, but you really don't have to because it's 1. So sine of 36 is 0.59, that's my opposite, and then I can get the hypotenuse, which is the height of my triangle, caught another horse, so the cosine of 36 is adjacent over 1. 1 cosine of 36 is 0.81. So now I have everything in this triangle, and I can get this triangle's area, 1/2 base times height, and if I didn't want to round it, I can actually put it in like this. 1/2 times sine of 36 times cosine of 36 is 0.24. Now that's just one of these, and I actually have 10 of those, because remember we're dividing each of those in half. So I multiplied it by 10 and got the area. So that is how I would do it. I would absolutely just think of it as triangles and figure out the areas of the triangle using trig. Here's another one, and I'm going to do it two ways. It's a dodecagon, that means 12. Dec is 10, and the do means 2 more than 10. And so it's a dodecagon, that's fun to say. We're told its radius is 8.3 and one side is 4.3. So there's my triangle that I have 12 of. I still need the height. Now, so I can do, first of all the way around is 360. I have 12 of these triangles, so my theta for one of these triangles is 30, but remember I only want half of one because I want it to be a right triangle. So I divide my 30 by 2 and get 15. Now I have this triangle. It's 8.3 on one side, half of 4.3 is 2.3 on the other, and I can get the